One of the next subjects that we're going to go on and talk about in PHP is how to get PHP to be able to work with databases. But before we get into that, I thought we might want to spend a quick video here just talking about databases themselves. Databases might be something that some of you have studied or learned about one way or another, but I'd be willing to bet that a lot of you have probably not done much with databases. So I just wanted to quickly go over kind of the basics of how databases work, what they are, and most especially some of the terminology that goes along with them so that you'll understand what in the world it is that I'm talking about here for the next couple of videos. So let's start off with, what do people mean when they're actually talking about a database? This is one of those things where I'm not even sure when people say database if they know exactly what they're talking about. And that's understandable because the term is used and abused quite often nowadays. So here's the way that I like to look at it. I would say that what a database really is that it's really basically just a file. It's a special type of file, sure, a file that's meant to be able to store data in a particular way, but really when it boils down to it, most databases are really just files or perhaps collections of files. So you could say in some ways databases are not really all that much different than something like a Word document. A Word document is, again, just another special type of file. It has its purpose, it does its thing, just like databases do. Another similarity that can be drawn between databases and something like a Word document is that a Word document requires that we have a piece of software, an application, like Microsoft Word, for example, to be able to access it. Well, the same thing's true for databases as well. For us to be able to work with a database file, it requires that we actually have an application. This application is usually referred to as a DBMS. DBMS is actually short for Database Management System. A DBMS is basically just a piece of software that gives us the ability to be able to work with these database files, kind of like Microsoft Word is just an application that lets us work with Word documents. More often than not, when I hear people talk about databases, what I think they're actually talking about is the database management system. Really, in a lot of ways, that's kind of the more interesting part of the entire thing. What is it that makes database management systems interesting? Well, there's a few different things they do that are pretty cool, pretty handy to us. One is that they provide concurrent access to the data that they store, so the data in the actual database files. The database management system can make that data available to more than one person at a time. It can allow the data to be shared. Because of that, the database management system also offers some level of security for our data. The database management system lets us create user accounts and passwords, for example, so that we can control who can access the data and what kind of access they actually have. But overall, one of the most important aspects of the database management system is that it provides random access to the data in the actual database files. Now, if you compare that to the text files that we've been working with up until this point, that we pretty much always have to read through in order, that's a pretty neat thing, being able to access the data randomly. It means that no matter where the data is in the database, we can access it just as quickly as if it was the very first thing listed in the file, the very first thing listed in the database. So pretty cool. It gives us much faster, much easier, much more seamless random access to the data that we need. Another one of the neat things that database management systems do for us is they make available to us a special programming language called SQL. SQL actually stands for Structured Query Language. SQL is a pretty neat little programming language. It's sort of kind of a generation ahead of PHP and a lot of the other languages that you've probably dealt with. It's actually what's called a fourth generation language, and what makes it special is that it's able to do the job that it's asked to do without having to be told how to actually do it. So unlike third generation languages like C++ or PHP or Java, where they can do pretty much anything, but they always have to be specifically told how to do the job, SQL, we basically just tell it what it is we want it to accomplish, and it is able to figure it out on its own. So that then means that fairly common tasks like being able to put data into a database or get data out of a database or being able to update or delete data that's stored in a database become almost trivial one-line statements using this SQL language. So that's pretty neat. How is it that SQL is able to do this? If you answered magic, Yes, you're right. Well, no, it's not really so much magic. Instead, what lets SQL work as well as it does is the fact that every database is actually built on a very specific type of structure. Essentially, every database at its lowest level is composed of characters. So anything we can type on a keyboard, numbers, letters, punctuation marks, and such, that's the fundamental piece of data that gets actually stored into a database. But that isn't all that's actually stored there. There's an arrangement to the way these things are put together, in that we can take a group of characters that are all related to one another and put them together into another unit called a field. Now, what do I mean, a bunch of characters that are related to each other? I mean, what if we take the letters J-O-H-N? If we take those 4 letters and put them together and say that together those are somebody's first name, then we would then consider those to be one unit, one field, and we would say that is, for example, the first name field. If we took S-M-I-T-H and put those letters together and said that's the last name field, then what we've done at that point is we've created 2 different fields. When we take groups of fields and we put them together, we then form another unit called a record. Records are collections of related fields, just like fields are collections of related characters. So if I take all the characters that make up a person's first name, all the characters that make up a person's last name, and all the digits that make up their phone number, and create from that 3 fields, the first name field, the last name field, and the phone number field, I could then have those 3 fields put together into a record. That record would then represent the information about whatever it is that I'm trying to represent information about. So in this case, we could say that was maybe a person record or a student record, whatever this first name, last name, phone number combination is supposed to represent. Well, what if I have more than one person record or more than one student record? Well, when I take all of the related records and put them together, at that point I have formed what is called a table. A table is just a collection of all of the similar records, all of the related records. So maybe I have a table that has all the student records in it. Each student record is made up of the fields that are full of the characters that describe a student. Maybe I also have an instructor table that is full of instructor records. Each instructor record is made up of fields that describes that instructors and is full of the characters that are needed to do that. When we take all of the different tables and put them together, that is then what we actually consider to be a database. So we could say that a database is a collection of related tables, which is a collection of related records, which is a collection of related fields, which is a collection of related characters. This is the basic data structure that most all modern databases are built on. Occasionally, the terminology can get swapped around on you a little bit. Depending on who you're talking to, what their experience is, what textbook you're reading, you might occasionally hear some different terms used. For example, fields might sometimes be called columns, and records might sometimes be called rows. So we have rows and columns instead of records and fields. It's all still the same basic idea. Different products, different databases, different books, different people, just sometimes put different labels on exactly what it is that they're talking about. So as an example, let's say that I wanted to create a database where I was going to store some information about music. Maybe I decide one of the important aspects about music that I want to store are the tracks of music that I have available to me on my computer. I might create a tracks table. The entire thing here would be considered a table. In that table then, each individual row, each line going across, is considered to be a record. Each one of those records then is made up of different fields. In this particular case, 3 fields. There's a number field, a title field, and a duration field that makes up each one of these individual records. If I take my tracks table and all of the data it contains and group it together with all the other tables that I might need to store information about music, then overall I could refer to this as my music database. When we're working with a database, it's very common that we need some way to be able to refer to specific records in a particular table. In order to do that, we often find ourselves needing to create what are called keys. Keys are basically ways of being able to identify particular pieces of information. Most of the time, when we create a key, we need a key that will never change and a key that is unique per table. That's the only way that I can guarantee that when I use a key, the database will know exactly every single time which record it is that I'm talking about. There's a few occasions where you might be able to use a piece of data that's already in one of your tables as a key, but more often than not, you're probably going to end up adding additional data to your tables simply to act as identification. For this particular purpose, what I almost always do is I add an ID field to most all of my tables. I can then make sure, because nobody else but me and the database, I guess, uses this ID field, I can make sure that the ID is both unique and unchangeable, which provides me a way of always being able to identify one particular record in a particular table anytime I need. When I use keys in this particular way, they typically become known as primary keys. And a good basic rule of thumb anytime you're working with a database is to make sure that every single record of every single table has a primary key. One of the things that we might occasionally use these primary keys for is to form what are called relationships inside our database. Relationships are basically the implicit connections between pieces of data in separate tables. For example, you and I can think about tracks and artists, and we can know, yeah, sure, there's a connection there. There's a relationship. Artists are the people who actually make the songs that are tracks. So, well, how would the database know that there was a connection there? We can use our common sense in order to be able to tell that there's a relationship. But is there a way that we could actually put that relationship down in the database itself so we could potentially make use of it through SQL, for example? There is actually. The keys play a big part in how we actually establish relationships in our database. For example, if I wanted to create a relationship between tracks and artists, the way I could potentially do that is by adding a new field to my tracks table. Here I've chosen to call that field the artist ID, and what I can do is I can take the actual IDs from the artist table, the primary key IDs from the artist table, and I can copy them over into the artist ID field of my tracks table. At that point, these numbers in the artist ID field of the tracks table become known as foreign keys, another type of key besides a primary key. The general idea with these foreign keys is that the foreign key value in the tracks table references or relates to the primary key value in the artist table. So using that, I can look at any particular track in the tracks table and I can tell exactly which artist created that track. And more importantly, since this relationship is now laid down in the database itself, I can potentially make use of that relationship through my SQL statements itself, allowing me to do things like say, what's the total duration of all the tracks that were written by the Foo Fighters, for example. There are a lot of these different relationships that typically exist in any given database, so that's something that you'll often see done. I would say that's probably actually one of the most important or one of the most common aspects of working with a database. Working with the records and the fields is relatively easy. The relationships, I've always thought, is where the real interesting part of databases lie. We could, of course, go a lot deeper into talking about database relationships and some of the other things that we can do with databases, but at this point, I think we've covered enough of the basic theory, the basic terminology, that hopefully you'll be able to keep up just fine when we start working with our databases from PHP.